Welcome back to the lab. It's actually the family room. And what I have here is this subwoofer, which was given to me by a friend. He said it was on its way to the trash. He picked it up thinking, well, maybe it's not that bad. Maybe there's something valuable in here. But then he asked me, do you think you can fix it? And I said, well, I can take a look at it. So the first thing you got to do if you're going to figure out how to fix something is find out what's wrong with it. And here's the interesting thing. If I go to flip this thing on, and I got to warn you, it's going to get loud. There is that horrible buzz. That's basically a 60 hertz hum, I believe. I don't have a scope to actually prove that, but I do want to prove that while the speaker's not rattling, I want to prove that it actually does work. So I've got some music queued up that has a lot of bass in it. Okay, I'm going to kill that. I know that was rather disturbing, and that's why I had to cut it short. But I have taken it apart and I have taken a look. There's nothing totally obvious. Like I said, the speaker's not rattling, it's just buzzing. So I don't think the speaker itself is damaged, though that's probably not going to be healthy for the speaker itself. So what I've done is I've already ordered the biggest capacitors that are on the power supply part of the board, part of the electronics in there. And so ultimately what I'm going to do is go ahead and try to replace those capacitors and see if I can get that buzz to go away. If the buzz goes away, we might be listening to actual subwoofer music. So I'll come back once I get it apart and ready to go. Actually, I just realized that what I had played before was towards the end of the song. It didn't have as much subwoofer, so I'm going to take another shot at this. Okay, there is some subwoofer in that. There's some very low bass. I don't know if that's coming through on the camera too well, but I'm going to go ahead and try again. Okay, I'm going to adjust it a little bit. Okay, hope that kind of demonstrated what I'm trying to show you here, that it is kind of working. I don't know how much of the problem is caused by that buzz, but if I can get rid of that buzz, that's the first step. Once I eliminate that, let's see what we get. Okay, so now we're in the lab, which is really just a retired darkroom. Actually, it's still in the process of being retired, so bit by bit we'll get the equipment out of here, and hopefully everybody's okay with the idea of me turning it into a little bit of a studio. But I had put a couple of screws in here. I removed everything else to look at it before. Put a couple of screws in just to be able to demonstrate it. And now I can show you what the innards look like. And it's not plugged in, but I'm actually going to have to disconnect. Let me see if I can flip it over and give you a little bit of a look. There's a couple of cables coming up here, and I need to get those disconnected. And the tricky part, this one's easy to get off. The other one is actually easy to get off, but it's harder to put back on because there's this wire here that kind of gets in the way when you're trying to reach back to take it off. So now I'm going to see if I can't reach back there. Can't quite remember if I need to, if there's an interlock on that. Let me see. And I suppose in theory I could take all of this apart, and then it would be, in some ways it might be easier to get that. This is the connection for the speaker itself. just the one connection because it's a subwoofer. It's got stereo inputs, but the speaker is not. And I just spotted something while I was doing that, but let me finish removing that. Gotta reach my hand in there, try and get the right angle on it, because there is a little tab that I need to push down, an interlock, if you will. There we go. Now that one's off. Now this is mostly free. The difference is the wire coming in. What have we caught on here? Something's... Oh yeah, that's right. There's a part of the difficulty here. These are wire nuts that are crimped on. I don't actually have those, so I'm gonna leave this as is. At least that's the plan for the moment. You can see glue here and glue there, and it's all turned brown, I think, because there's been heat in here. And where was the thing I just spotted a minute ago? It was right in here. That's going to be hard to show you on camera. I don't know if that's glue. It looks like there's a little piece of rubber here. I'm hoping that's not the cause of the problem. Alright, well, the components that I was planning on replacing. Let me get that out of the way. And actually, for that matter, since I'm going to end up taking this off here to get to get the speaker reconnected eventually, I might as well disconnect this. And this is just a matter of kind of wiggling it back and forth until it comes out. I don't think there's an interlock on this one, but there are a couple of keyways. I'm hoping you're actually seeing that. A couple of keyways to keep it in the right orientation, and also to ensure that if you look at the wires here, it's red, black, red, black, red, black, red. Which backwards is red, black, red, black, red, black, red. So you can't use the wires to determine which direction this goes, but fortunately these two little keyways make it so you end up plugging it in correctly. So that's off. Now, unfortunately, these capacitors are glued down, so what I'm going to have to do is go get a knife and break that connection. And then ultimately I'm going to have to get on the underside here. Oops, I just touched that. You know, I shouldn't really touch that. Let me see if we can't discharge anything that might have been... Nope, no spark on that one. No spark on that one either. And then there are two smaller ones, which I also got replacements for. No spark there. No spark there, so we're good. They're discharged. Now, what I fear is that they're not able to hold a charge, but I got to go get a knife, a good sharp utility knife, and I'll be able to cut that adhesive. Okay, I got the knife, and I will say that a good sharp utility knife is always more useful than one that's dull, but there is some danger. If you're not careful, you could get cut by a utility knife, and I have actually cut the tip of my finger off in the past, which wasn't pleasant, but I'm okay. I survived that. And you know what, this is going to take me a minute, so I'm going to go ahead and pause here, and I'll come back once I've got some of this adhesive cut. And I suspect I'm going to have to do that again, even after I'm going to have to remove these first two to be able to get to the other two. So, and then I'll have to do it in reverse. And I think they're probably glued down because these are large components and you don't want them vibrating too much. But when I do this repair, I don't know that I'm going to actually be able to glue them back down. I could get some hot melt glue and see what happens with that. But let me pause here and see if I can get that cut. Okay, that job is done. And by now my soldering iron is probably heated up, which I started before I started recording this part of the video. So the fun part, let me see if I can't turn this way, make it a little bit more visible to you. Wow, okay, that could work. Yeah. The first thing I've learned from Big Clive, bigclive.com, or Big Clive's YouTube channel. I'm just giving free plugs away here because these are the people that I've kind of learned things from, and I think they have channels that are worth seeing. Big Clive tends to do more sort of he would take this circuit board, take it out, reverse engineer it, and draw the schematic and show you what's going on. If he was trying to repair it, he does a few repairs on his channel, but mostly what he does is tear downs and explain what's going on so you understand how the circuitry works. But the first thing he would do if he was trying to remove a capacitor is add fresh solder to the solder joint, which is what I'm doing here, because it makes it easier to remove the solder if it's fresher. When it dries out, it's a little harder to remove. Wow, that's just not, it doesn't really want to melt. Alright, well that's got something on it, so now we pull out the handy dandy solder sucker, which is one of these that, let's see if I can just sort of show you. Well, I'm kind of out of frame here. I'm going to push it down and that primes it, and then there's a button here that when I hit that button it'll actually suck up the solder, but the only way it can suck up the solder is if the solder is soft, which means I need the soldering iron to melt it. Put that there, line her up. Nice. Okay, there's still some left, but that's okay. Now I'm going to prime it again. Oop. I just saw a piece go flying out when I did that. Maybe I can show you that after I get this heated up. And that took out a bunch. And let's see if I can't, I don't necessarily want to drop stuff into the speaker here. So let's see. Can I get an angle doing it this way? Yeah. Oh, didn't see the piece fly out. We're going to give it another shot. I need to prime it again. Let me get the solder melted. You know what? It's fighting me. So I'm going to put a little bit more solder on it. The problem is, it's not just old solder, it's that for the last several years there's been this reduction of hazardous substances, ROHS, that you see on a bunch of things, and the idea is basically lead is a dangerous chemical, especially if children are exposed to it, but it's mostly more about like consuming it. That really kind of started with lead paint and kids that were chewing on windowsills and stuff like that, and then they were having brain damage, or they weren't doing so well. So lead became this thing that, oh, you shouldn't have lead in anything. Well, in solder, I mean, unless you let your kids start sucking on circuit boards, I don't see where it's really that big of a deal. But unfortunately, the lead-free solder tends to be a little harder to work with. You need more heat and other things. So I've now done this a couple of times. The next trick is I'm going to try and wiggle the capacitor from the other side and heat it up and hope that that's enough to get it off. Alright, it's fighting me. I think it's glued down, so I'm going to go ahead and pause here and come back once I get all of these capacitors removed. Alright, the deed is done. I've removed all 4 capacitors. I've got 2 of these. which are 1000 microfarad 35 volt. I bought 2 of them. So there's one, there's the other. You can see a little remnant of the adhesive, and the difficulty in removing was a combination of my solder sucker getting clogged, which I hadn't realized, as well as the adhesive and some of the solder, I think, just being that lead-free stuff, which is, you need a much hotter iron, and I'm used to dealing with my old-fashioned, like 30-plus-year-old iron, which is still working. But and here's the larger ones, which these are what they call snap-in. They've kind of got that particular, I'm hoping that it's coming out, style of pins on them. I bought through-hole, but I think we're going to be okay. Really, the most important thing is that's, I got to make sure I get the perspective right. Hope I got that right. 4700 microfarad, 63 volts. So, and I got 2 of them, and you can see the adhesive. Anyway, so that's those. The next thing I want to do is actually, I want to do a little bit of a test. So I want to actually get this. What did I do? I twisted it. That's what I did. Okay. I'm just going to drop this back in for a minute. And yes, I realize that this will be upside down. Yeah, so what I want to do is actually test the capacitors. And it's acting about the same. Well, it could then be something else that was wrong. I don't mean to always assume when I'm trying to repair electronics that it's the capacitors, but that seems to be a fairly common problem, which is why I just decided to go after the capacitors on this one, because it's simpler for the moment. We'll try them out. Yeah, it cost a little bit of money, especially for the bigger ones. These are about $4 a pop. But I've got that. I have my replacement capacitors, my good old DigiKey box here. So I'm going to go ahead and pop those in and solder them on, and then we'll get to testing. You know, it occurs to me to show you one more thing, and that is, if we look at the board, let me see if I can twist it around here, and I'm hoping that's coming in, yeah, down in here. I just want you to see just how huge the area is that they reserve for that capacitor. And ultimately, most boards are marked in some way or another to tell you which side is plus and which side is minus. In this case, I hope it'll come through. There's a tiny little plus sign next to this, but then there's all this hashing over here, which is your negative side. And they did that on all 4 of the capacitors that I removed, so it makes it easier for me to figure out which direction to put them in. You know, I got 3 of these soldered in, and it occurred to me I could take the replacement and run the same test that I did before. So it's holding a charge. So I know this capacitor is good. I'm assuming the others I put in are good because they're brand spanking new. They're all Nichicon or similar high quality capacitors. That's all I will buy is high quality capacitors, and I try and match the sizing and all of that. So that's where we are on that. Now I'm going to put the last one in, cut the leads, and then we'll be able to test. Okay, folks, now it's time for the first magic smoke test. It's plugged in. Let's turn it on and see if smoke comes out. No smoke. No buzz. That might be a good thing. That might be a very good thing. All right, now it's time to go hook it up to an actual audio source. So back to the family room where the lighting isn't so great, but back there, because really this is more about the sound than it is about the light, isn't it? So I'm going to head back there and set up, and I'll meet you there in a minute. Okay, we're all pretty much set up here. We're going to go ahead and give it an actual test. I'm going to have to reach over and flip a bunch of switches kind of from out of frame, but you can see a little bit of the TV, you can see a little bit of this beast here, and we're going to give it a shot. There's the music coming up. Okay, let's turn her on. There's a setting for the crossover where I can go from, I think it's 40 to 120, and I'm going to basically set it about midway. The volume control I'm going to start all the way down and come back up. There's also a switch to go from normal phase to 180 degrees out of phase. So let's see, I think that's, I'm not sure which one is on, but right now it doesn't really matter. That's really more a matter of once you get everything else set up. What we're trying to prove is that this thing works or doesn't work. So I'm gonna put it, there's also a switch that goes from off to auto to on. So I'm going to try auto. And that's when it makes that. So now we got white. I guess that's white noise, but just at a very low frequency, if that makes sense. I suspect the rattling is actually because I haven't put all the screws into the plate holding the circuitry onto the back. Yeah. Oh well. I guess this isn't the success I was hoping it would be. It means I've got to go back into it and try and figure it out. Or just actually talk to my friend and see what he wants to do as far as moving on. Actually, if you ignore the white noise, even at the lowest volume, it's still actually working. Let's try this one. Actually, one more thing I'm going to try. I only have the right channel hooked up because I wanted to be able to have the left channel for the TV. So let me go ahead and try that real quick. Let me switch that around. Hear it all that well. It's working, sort of. I've still got this white noise problem, which could be the amplifier chip. I need to look that up and see what it might be, and see if I can order another part, or if it's just going to turn out that this isn't worth trying to fix. I mean, as it is, I'm about $10 in on parts, but it was a risk I was willing to take for the sake of the video. But what I've done now is I've hooked both left and right to the back of this, so there's no monitor on the TV. You're not hearing anything but the subwoofer itself, how it responds to the input. Unfortunately, there's still the white noise. But hopefully you can hear. There is something going on. So the speaker is still good. I can try and turn up the volume a little bit and see what happens there. Yeah, I think what happens once it gets beyond a certain point, then other parts start to rattle, because you're really talking about a lot of power coming out of that speaker. It's shaking the cabinet really hard. So that's kind of where we are. I think I'll wrap it up here, and